Hello, welcome again. We are covering the subject thermodynamics for civil services mains, IFS, and various gate exams. And we have covered the topic first law of thermodynamics for closed system. Now we'll solve some questions based on that topic. Question number one is a closed system undergoes a cyclic process for the net work done by the system on the surroundings. Which of the following statement is false? Option A, network is always zero. Option B, network is cyclic PdV if the process is reversible. Option C, network can be negative. Option D, network can be positive. So here this is the cycle, and for Q1 is heat supplied and Q2 is heat rejected. And according to first law we know that the cyclic heat supplied is cyclic equal to cycle work done. So when Q1 is more than Q2, the work will be positive. Okay. So when Q1 is less than Q2, the work will be negative. And when Q1 is equal to Q2, the work will be 0. And for a reversible process, cyclic PdV will work done. So here, when this Q1 is equal to Q2, then work done is 0. It is not always 0. So statement 1 is wrong. Network is always 0, that is wrong. Second question, which of the following statements are true with respect to heat and work? 1. They are boundary phenomena. 2. They are exact differential. 3. They are path functions. Option A both 1 and 2. Option B both 1 and 3. Option C both 2 and 3. And option D 3 only. So heat and work are boundary phenomena, whereas this these they are no, because they crosses the boundary. Heat crosses the boundary, work crosses the boundary, so they are boundary phenomena. And they are path function, they are not the point function. So C is also correct. Second is not correct. So answer is B, option D. Next is question number 3. The internal energy of an ideal gas is a function of option A temperature and pressure, option B volume and pressure, option C entropy and pressure, and option D temperature only. So answer is temperature only. So that is a Joule's law. Answer is D. Next is question number 4. A paddle wheel is inserted in a rigid insulated tank containing 10 kg of air. Cv is equal to 0.718 kilojoule per kilogram per degree Kelvin. A torque of 100 Newton meter is applied on the paddle wheel to rotate it at 60 revolution per minute for 2 minutes. At the end of process, the increasing temperature of air in degree Celsius is option A 0, option B 5.25, option C 10.5, and option D 21.50. So here work is applied for 2 minutes. So that is equal to 2 pi mt into u power, and this is time is 2 minutes. So it will be 2 pi, n is your 60 revolution per minute, and t is 100. So and time is 2. So that will be the work supplied. Okay. And this work supplied will be converted into internal energy, or change in internal energy, because the tank is insulated, so there will be no heat rejected or received from the tank. So all the work will raise the internal energy. So internal energy, change in internal energy, and CVTF minus TI is equal to this. So TF minus TI comes out 10.5 degree Celsius. Option C is the answer. Next, question number 5. Water is heated at atmospheric pressure from 40 degrees to 80 degrees Celsius using two different processes. In process 1, heating is done by a source at 80 degrees Celsius. In process 2, water is first heated from 40 to 60 degrees Celsius by a source at 60 degrees Celsius, and then 60 degree to 80 degrees Celsius by another source at 80 degrees Celsius. Identify the correct statement. Option A, enthalpy change of water in process 1 is greater than enthalpy change in process 2. Option B, enthalpy change of water in process 2 is greater than enthalpy change in process 1. Option C, process 1 is closer to reversibility, and option B, process 2 is closer to reversibility. So here water is heated in both the cases from 40 to 80 degrees, and enthalpy is the function of temperature only. So in both the cases the temperature is same, so answer cannot be option A or B. Enthalpy change of water in process 1 is greater than enthalpy change in process 2, that is wrong, and this is also wrong. Change of water, enthalpy change would be same for two processes, so these are not the answer. Whereas in process 1 the source of heating the water from 40 to 80 at 80 degrees Celsius. So when the water is at 40 degrees Celsius, there is few temperature difference between the source and between the sink. So which can be the reason of irreversibility. Whereas in second case, the water is heated from 40 to 60 from a source of 60 degrees Celsius. So here the temperature difference is only 20, and here the temperature difference is only 20 for second part, because here water is heated from 60 to 80 from another source at 80 degrees Celsius. Okay. So process 1 is not close to reversibility. It is highly irreversible because source temperature is far away from sink temperature, whereas process 2 has closer temperature difference, so process 2 is closer to reversibility. So answer is option D. Answer is option D. Next, the statement which is not a consequence of first law of thermodynamics is option A, heat is a path function. Option B, energy is a property of a system. Option C, energy of an isolated system is not conserved. Option D, a perpetual motion machine of first kind is not possible. So here heat is a path function, that is correct. Heat and work are path function. Energy is a property of the system, that is also correct. That we have also tried. Energy of an isolated system is not conserved, that is wrong. So energy of an isolated system is conserved, that we have tried. And a perpetual motion machine of first kind is not possible, that is also correct. So answer is option C. Next is, an ideal gas has a molar mass of 40 kg per kilomole. Take R is equal to 8.314 kilojoules per kilomole per degree Kelvin at a pressure of 2 bar and a temperature of 300 Kelvin. The volume in meter cube of 1 kg of this gas up to 2 decimal is dash. So R bar or universal gas constant is 8.314 kilojoules per kilomole per degree Kelvin, and characteristic gas constant is R bar by molecular mass of the day. So that R characteristic gas constant comes out as 0.20785 kilojoules per kilogram per degree Kelvin. And using PV is equal to MRT, pressure is 2 bar or 2 Newton per 5 meter per meter square. V is volume, M is 1, and R is your 0.20785 1000, and T is 300. So from this volume comes out as 0.31175. Next question is, the first law of thermodynamics is also known as conservation of option A mass, option B momentum, option C energy, and option D speed. So answer is energy. It is conservation of, related to conservation of energy. So these are the first 8 questions.